Good morning, students. Today we are going to discuss the few topics from the chapter 5, which is laws of motion. Now, already we have discussed few topics in last class. Let me continue our discussion. And the topic which we are going to discuss today is your conservation of linear momentum. Now, I think you have heard this one, I think in class 9 maybe. But here what we'll do, we will try to explain it in more elaborate way. Now, conservation of linear momentum, what it says that the total linear momentum of an isolated system remains constant. Isolated means no external force is applied on the system. Neither external force nor internal force exists in the system. So as per the statement, the total linear momentum of an isolated system remains constant. Now from Newton's second law of motion, if we consider constant of proportionality is your 1, then F equal to dp dt, that is force is equal to rate of change of momentum. Now for an isolated system, F equal to 0, so it means that dp dt equal to 0. Now variation of momentum with respect to time is 0. It means that momentum is constant. So this is a simple explanation of the conservation of momentum, linear momentum basically. Let me explain it in elaborate way. Now you see in the system you do have two objects A and B moving with velocity u1 and u2 in the same direction and having mass m1 and m2. Now let me consider u1 is greater than u2. So what happened on the way? There is a collision between A and B. Now let me consider FAB is the force exerts on A by B and FBA is the force exerts on B by A. So these two forces are in opposite direction, equal and opposite direction. Now after collision, this collision basically lasts for a very short time. Let me consider that time is your delta t, small t. And after collision, the objects A and B moves with different velocity, one with v1 and another one with v2. Now obviously it is the vector quantity, so always use the notation as we have given here. So it is your v1 vector and v2 vector. Now from Newton's third law, every action has an equal and opposite direction. So let me consider FAB vector equal to minus FBA vector, because they are in oppositely directed. Now FAB is the force exerts on A by B. So what happened? The momentum of A will changes. So as per the Newton's second law, force is nothing but the rate of change of momentum. So change in momentum for A is your finally is your m1 v1 vector minus m1 u1 vector, and divided by the short time during which the collision exists gives you the force. And similarly FBA is the force exerts on B by A. So momentum of B will change. So the final momentum for B is your m2 v2 minus m2 u2 and divided by delta t, obviously, because rate of change of momentum is the force. So here we have written where delta t is the time during which collision exists. Now delta t goes off. Let me simplify. m1 v1 vector minus m1 u1 vector minus m2 v2 vector plus m2 u2 vector. So m1 v1 vector, let me take the v1 in one direction and v1 in the sense m1 in one direction, one side, and m2 is in another side. So if you simplify, m1 v1 vector plus m2 v2 vector equal to m1 u1 vector plus m2 u2 vector. Just a simplified form, this one, m1 v1 vector, so m2 v2 vector, this side it comes plus, and m1 u1 vector plus m2 u2 vector. So m1 v1 vector plus m2 v2 vector is nothing but the total momentum of the system after collision, and m1 u1 vector plus m2 u2 vector is nothing but the total momentum of before collision. So this is the law of conservation of momentum. It means the total momentum of the system remain constant before and after collision. Now let me try to apply this one in some application, that is in numericals. Now the first numerical, it says that a bullet of mass 100 gram is fired from a gun of mass 20 kg with a speed of 50 meter per second. Calculate the recoil velocity of the gun. So here we'll consider that before firing the total momentum is your 0 because no velocity is there on the system. So after firing there exists momentum. So as per the conservation of momentum, small mv plus capital M, small mv plus capital M, capital V equal to 0. It means this is the final momentum after firing, and initial momentum before firing is 0 because the system is at rest. So as per the values given, m define the mass, small m define the mass of the bullet, so 100 gram, it means 0.1 kg, and capital M is the mass of the gun, that is your 20 kg, and small v is your mass of the bullet, 50 meter per second, and capital V you have to find, that is the recoil velocity of the gun. So if we substitute here 0.1 into 50 plus 20 V, so if we simplify, it comes out to be 5 plus 20 V equal to 0, so 20 V equal to minus 5, so V is here minus 5 by 20. So if you multiply numerator and denominator by 5, you will get minus 0.25 meter per second. So negative sign shows that the recoil velocity is opposite to the velocity of the bullet. I think you have understood here what is the thing you have to keep it in mind. Before firing the system is at rest, it means the total momentum is 0, and after firing the momentum changes. So this is one application. Another application, let we consider this one. A bomb of mass 10 kg explodes into two equal fragments. Two equal fragments. Be careful. It means that each fragment has a mass 5 kg. At what angle these fragments fly apart? So again, before explosion, the system is at rest. It means the total momentum of the system is 0 before explosion. So after explosion, there exists momentum. So from law of conservation of momentum, m1 v1 plus m2 v2 equal to 0. So as the fragments splits with equal mass, that's why each mass is 5 kg. So 5 v1 plus 5 v2. So 5 goes off, v1 equal to minus v2. So it means that negative sign is there. The fragment moves in opposite directions. Now I am keeping this one for you. You try this one and try to find out the answer and check the answer. A hammer of mass capital M strikes a nail of mass small m with a velocity of 20 meter per second into a fixed wall. The nail penetrates into the wall to a depth of 1 centimeter. Calculate the average resistance of the wall to the penetration of the nail. And the answer they have got is F equal to minus 2m square, capital M square, small m plus capital M into 10 to the power 4 Newton. Please check out and try to find it out. If you have any problem, please specify and we'll try to solve. So this is a very important topic, and please check out the revised syllabus before starting your chapter. So please go through, and if you have any difficulties, you can ask. Thank you.